This video will show you how to expand a high-order binomial using the binomial expansion theorem and Pascal's triangle. Example: expand p plus q quantity raised to the fifth power. Solution: this is a simple expansion as long as you understand the pattern. P plus q to the fifth power is equal to some number times p to the 0, q to the 5, plus some number times p to the 1, q to the 4, plus some number times p to the 2, q to the 3, plus some number times p to the 3, q to the 2, plus some number times p to the 4, q to the 1, plus some number times p to the 5, q to the 0. Now you should see a pattern here. Notice that 0, 1, 2, 3, 4, 5 are the exponents, incrementally increasing from 0 to 5 for the p variable. Notice also that the exponents of the q variable decrease from 5 to 0 incrementally as 5, 4, 3, 2, 1, 0. Now I want you to notice that the sum of all the exponents for each term has to add up to 5, precisely because we are expanding p plus q to the fifth. So notice that 0 plus 5 is 5, 1 plus 4 is 5, 2 plus 3 is 5, 3 plus 2 is 5, 4 plus 1 is 5, and 5 plus 0 is 5. That is the pattern that we must have. So the question now is, how do we get these missing terms here? Now these missing terms actually have a name, a term. They are called binomial coefficients. And we can obtain these binomial coefficients using the famous Pascal's triangle. Now if you've never seen it before, I'm going to write it for you. We start off with a 1 in the upper vertex, and now we put 1 on the edges. And I want you to notice here that 1 plus 1 equals 2. Now, we put the 1 here, and I want you to notice that 1 plus 2 is 3, and 2 plus 1 is 3. See, 1 plus 2 is 3, and 2 plus 1 is 3. And let's put the 1s on the edges, and now notice 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and let's make another row. We put 1s down, and 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and I want you to notice here that there is a 5 here, and there is a 5 here. That's how you know that it is time to stop. And we could put the coefficients into this binomial expansion. And the coefficients are 1, 5, 10, 10, 5, and 1. And that is the end of this problem, actually. I want to give you a little more insight into this. In the land of Pascal, we don't start counting with the number 1, which would seem obvious. We actually start counting with n equals 0, and then we go to n equals 1, and then we go to n equals 2, and then n equals 3, and then n equals 4, and then n equals 5. And here the symbol n represents the exponent in the expansion of p plus q to the n. Here, the role of the n is played by the number 5. Homework. Problem number 1. Expand p plus q to the 7th power. 2. Relate the following binomial expansions to Pascal's triangle. A is p plus q squared. Please don't use the FOIL method. Please use Pascal's triangle, but of course you're going to use n equals 2. And then if you have to use the FOIL method, compare and contrast your answer with the one you get using this method here. P plus q to the 1, it's actually very simple, but sometimes simplicity can be very confusing. And finally, p plus q to the 0. This will take you a little time to reflect on this, perhaps, but you should see a clear relationship with Pascal's triangle.